Okay, in this video, I'm going to show you how to write equations of exponential functions that have been translated. Before we get into the examples, let's take a look at some of the parent functions. On the left, I have y equals 2 to the x. Here's the graph of it. You can see the y-intercept is at 0, 1. I also have another, we're going to call these reference points. I have another reference point at 1, 2, and then I have an asymptote here at y equals 0. I want you to notice that the distance from the second reference point down to the asymptote is 2 vertical units away. And of course, the distance from this first reference point, which is the y-intercept, is 1 unit away. Over here, for y equals 3 to the x, I have a similar pattern. This reference point here is 3 units away from the asymptote, and the y-intercept is 1 unit away from the asymptote. And if you actually do that as a proportion, we've got 3 units over 1 unit, and their base there, or your growth rate in this case, would be 3. And over here, 2 over 1, your growth rate is 2. Now here we have some exponential decay examples. Here's your y-intercept, and here's another reference point. So this reference point on the left is 2 units away, and then this reference point is 1 unit away. The ratio, again, from doing the second one divided by the first one would be 1 divided by 2, and your base or your decay rate here is a half. You can also just reason that because it is a decay, but the growth rate or decay rate or the base of the exponential expression must be less than 1. I could, although it would be a little trickier because this point is not labeled, but this is the point at 1, 1/2. And so then you can also reason that this is a 1/2 and then this is a 1. So that's another way that you can get that the ratio, excuse me, or the decay rate is a half. And then over here, for y equals 1/3 to the x, that vertical distance is 3, that vertical distance is 1, and so that proportion would be 1 divided by 3. Similarly, this point right here, even though it's not labeled, that point is at 1, 1/3. And so you can also do it that way. 1/3 divided by 1 is 1/3. Let's take a look at our first example here. So here's the graph that we're given. We're told that it passes through the point -2, 0. There it is. -3, 1. There it is. And it has an asymptote at y equals -1. There it is. We want to write it in this form, a times b to the x minus c plus d. Sometimes you'll see textbooks or other teachers will write this as a times b to the x minus h plus k. It really doesn't matter. It's just a matter of personal preference. Easiest thing to do actually is to identify the d value, because that d value is going to be the exact same thing as that's your vertical translation, and the easiest thing to translate is the asymptote. So this asymptote has been moved down 1, so that d value is going to be -1. So the a value is going to be the vertical distance from the first reference point to the asymptote. So this is our first reference point, or the one that's like closest to the asymptote, and you can see that it's 1 vertical unit away from the asymptote, because this is the point, if it had not been translated to the left or down, this would be your y-intercept. And you can see that it's still just 1 unit away from the asymptote, just like they are on the parent functions there. Okay, so in this case, a value is just going to be 1. For our b value, this is where we're going to do that ratio that I was talking about. So this is a distance. The second reference point is 2 units away from the asymptote, and then of course that one is 1 unit away from the asymptote. So that ratio is going to be a 1/2. We know that it's going to be smaller than 1 because this is exponential decay. So it's always going to be the leftmost one on the bottom and then the rightmost one on the top. And then for the c value, like I said before, this reference point right here is the one that was originally on the y-intercept, or on the y-axis, it's the y-intercept, and it's been shifted to the left 2, so that c value is -2. So putting that all together, we're going to have y equals 1 times 1/2 to the x plus 2, because it will be x minus -2, with that -1 on the outside. Okay, let's take a look at example number 2. Here's the graph. We have these reference points here, -1, 4 and 0, 8, and we want to write the equation for it. Like I said earlier, the easiest thing to do is to identify the d value, because that's just going to be your asymptote, which is at +2 this time, so d value is going to be 2. The a value, again, that's going to be the distance of the first reference point down to the asymptote, so that's 2. The b value, that's going to be that ratio. Now I see that this is exponential growth, so this distance here from 8 down to 2, that's a distance of 6. And this reference point down to the asymptote, that's a distance of 2. So that's going to be 6 divided by 2, so 3. And then finally, for the c value, this is the point that would have been your y-intercept, but it's been shifted to the left 1, so the c value is -1. So putting that all together, we're going to have y equals 2 times 3 to the x plus 1 plus 2. Now you may wish to pause here before example number 3 and try this one on your own. Now what I tried to do here is actually trick you a little bit by giving you 3 different reference points. What I want you to notice for all of these problems is that these reference points are always consecutive reference points. So they are horizontally just 1 unit away from each other. And that's very important in this process. So we're going back to example number 1, you'll notice that these are just horizontally just 1 unit away from each other. And looking same thing at number 2, these are horizontally just 2 consecutive reference points. So I'm going to show you 2 ways to do this one. First, using this reference point, and then I'll do it again using that reference point and that reference point. So if I use first -1, -1, and 0, 5, well, we know that the d value, or the asymptote, is down there at -3, so the d value is -3. The a value, again, that's from the first reference point down to the asymptote, so in this case, that's going to be 2 units, so a is 2. The b value, that's going to be that ratio of the second reference point over the vertical distance to the asymptote and that other reference, the first reference point down to the asymptote. So this is a distance from 5 down to -3, that's 8 units. And then the reference point here, that's 2 units away. So that makes your b value equal to 4. And then the c value, if we're considering this our first reference point, that one had been the y-intercept, then that's been shifted left 1, so c is -1. So putting that all together, we would have y equals 2 times 4 to the x plus 1 minus 3. Now let's do it again, but this time I'm going to use the reference points -1, -1 and -2, -2.5. So the d value, again, that's just your asymptote, so that's still going to be -3 like in the other way I did it. Your a value, however, we're looking at this being your first reference point, and that is only a half a unit away from the asymptote. So for A, we're going to use a half. And then for B, we've got this vertical distance from the second reference point to the asymptote, that's 2 units away, over the distance from the first reference point down to the asymptote, which is a half a unit away. So 2 divided by a half, well, that's equal to 4. And then for C, again, if we're thinking about this -2, -2.5 as being the first reference point, that is 2 units away from the axis, so the C value is going to be -2. So putting that all together, we're going to have y equals 1/2 times 4 to the x plus 2 minus 3. Now, you've noticed that these are 2 different equations for the same function. Well, I'm going to show you how these 2 different equations are actually the same.